guys, welcome back to my YouTube channel. Today I'm going to solve day 9 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 974, subarray sums divisible by k. Okay, so in this problem we have given an integer array nums and an integer k, and we have to return the number of non-empty subarrays that have a sum divisible by k. A subarray is a continuous part of an array. Okay, so here in the example 1, as you can see, there are total 7 subarrays with the sum divisible by our k, which is equal to 5, right? So here this is one subarray. So just do the summation of all the elements of this subarray. So what is 4 plus 5? 9. 9 minus 2 is 7. 7 minus 3 is 4, and 4 plus 1 5. So 5 is completely divisible by this k. Okay, and this here also 5 is divisible by 5. Here also 5 is divisible by 5. Here 0 is divisible by 5, completely divisible, right? Here 0 is also divisible by 5. Here 0 minus 5 is also completely divisible by 5. Okay, and here minus 5 is also divisible by 5 completely. Okay, so in the end, how many subarrays are there in total? So total 7 subarrays are there, right? So we are returning the output as 7. Okay, so for all these subarrays the sum is divisible by k. Okay, 5. Okay, so now let's understand this problem using approach 1. Okay, so approach 1 is going to be very simple. So in approach 1, this is my nums array, right? So what I'm going to do, I'm going to take 2 pointers. So let's say I is representing nothing but my left pointer and j is representing nothing but my right pointer. Okay, so here first my I is fixed at this position and my j is at this position. Okay, so now 4 is divisible by 5? No, 4 is not completely divisible by 5. Okay, so now my j is going to move to the next position. Okay, now my j reaches at this position. So now 4 plus 5, 9. 9 is divisible by 5? No, 9 is not divisible by 5, right? Then my j is going to reach to the next position. J moves to this position. Okay, j reaches here. Then again sum of this subarray 4 plus 5 plus 0 is divisible by 5? No, right? Then my j is going to move forward. Okay, j reaches here. So now tell me, 4 5 0 minus 2 is the summation of this is divisible by 5? No, it is not divisible by 5, right? Then my j is going to move to the next step. So tell me if this is divisible by my 5. So no, right? 9 minus 2 7. 7 minus 3 4. 4 is not divisible by 5. Okay, so now my j is going to move to the next position. J reaches here. So tell me, this 4 5 0 minus 2 minus 3 1 divisible by 5? Yes, it is divisible by 5, right? 4 plus 5 9, minus 2 is 7. 7 minus 3 4. 4 plus 1 5. 5 is divisible by 5. Okay, so this is one subarray which is completely divisible by 5. Okay, so see here in my output this is there. Okay, 4 5 0 minus 2 minus 3 1. Okay, it is there. Okay, so once all this is done, okay, so now in the next step what is going to happen here? So right now my I is going to move to the next position. So now my I is going to reach to this position and j is going to start from here. J first here, then my j go 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 here. And once this cycle is completed, then my I is going to start from this position and j is going to also start from this position. Okay, this is done, right? So I hope that you guys are clear with this simple approach. Okay, so here I have already written the code using this same approach, but in this case, see, my time complexity is going to be of n cube, right? And 38 out of 73 test cases passed. So here, see, same thing I am doing, right? Left is starting from 0 to less than n. Okay, so here my time complexity is going to be O of n, right? And then my right pointer is also going to start from my left, and it is also going to run till less than n. Okay, so here also my time complexity is going to be O of n, and inside this I am calling one helper method, right? And inside this helper method I am running one more loop, okay, for the summation. So how many times it is going to run? It is going to run for also in the worst case scenario, let's say O of n times. Okay, so in general it is going to run from right minus left, right minus left plus 1 times. Okay, so in general worst case scenario, let's say it is also going to run for O of n times. Okay, so here I am doing the summation, and here I am returning true or false. I am returning true or false. Okay, if the match dot absolute sum modulus of k is equal to 0, then I am returning true or false. Okay, so if it is true, then I am incrementing the count. Okay, and in the end I am just returning the count. Okay, so this is my approach one. But here in this approach one, time complexity is O of n cube, and only due to this only 38 out of 73 test cases passed. Okay, so now let's move to the approach 2. Okay, so I hope that you guys are clear with this approach one code. Okay, so now in the approach 2, see here in the summation function we are also using O of n time complexity, right? So what I am trying to do here in my next approach, I am going to do the summation in O of 1 time complexity. Okay, I am trying to do this some summation part in O of 1 time complexity in the next approach 2. Okay, so now let's do the approach 2. Approach 2 is nothing but using cumulative sum. Okay, so in this cumulative sum, what I'm going to do here, so let's see here. Okay, okay, so this is 4, right? Here I'm going to write it as 4. Okay, so this is my cumulative sum array, right? Let's say. Okay, so here 4, and then 4 plus 5 is 9, 9 plus 0 is 0 or 9. Okay, and then 9 minus 2 is 7, 7 minus 3 is 4, and 4 plus 1 is 5. Okay, this is my cumulative sum, right? This is a cumulative sum array. Okay, so this is what I am going to find in my approach 2. Okay, so now after finding this cumulative sum, let's suppose I want to find the sum of this part. Okay, I want to find the sum of this part. Okay, so now see how I'm going to do this. Okay, so first tell me what is the sum of this part. 5, 0, minus 2. Sum of this part is 3. Right. Now go to my cumulative sum array. Okay, in this cumulative sum array, what I'm going to do, I want to find what is the cumulative sum of this index. Okay, I want to find the sum. Let's suppose here my right pointer is at this position and my left pointer is at this position, let's say. Okay, so here what is now I'm referring to my cumulative sum array. So here value is 7. What is the value of my nums of right? Okay, this cumulative sum of right. So 7 minus, here I am subtracting this value 7 minus 4. Okay, so 7 minus 4 is nothing but 3. So this value minus this value is directly going to give me the result of this value. Okay, so in between I want to find the result, right? So here till here my cumulative sum was 7, and I subtracted this part, which is directly going to give me the result of this part, 5, 0, minus 2. Okay, so I hope that this is clear. So here also I am getting the time limit exceeded error, but time complexity this time is going to be O of n square. And here see 68 out of 73 test cases passed. Okay, here it was 38 out of 73, now 68 out of 73 using n square. So here inside this I am finding the cumulative sum. Okay, this is my cumulative sum array. Okay, cumulative sum array. Okay, here I am updating my cumulative sum array values. Then again using left pointer and right pointer I am iterating. Okay, and in the helper method I am directly checking the sum. Okay, sum is nothing but nums of right minus, if left is greater than 0, then num of left minus 1. Okay, so this is what I am doing, right? Nums of left minus 1. Until here I want to find, so here left minus 1. Here 7 minus 4 is directly going to give me the summation of this part. Okay, this is done, right? And here I am returning true or false depending on this. If absolute sum modulus of k is equal to 0, then it is going to true, otherwise false. So if it is true, then I'm incrementing the count, and in the end I'm returning count. Okay, so this is my approach number 2. Okay, so now let's move to the approach number 3. Okay, so before solving this problem using approach 3, let's discuss few basic mathematics. Okay, so I hope that you guys are already aware of this formula. Dividend is equal to divisor into quotient plus remainder. Okay, so here first let's say if I want to divide this number 15 by 7. Okay, so can I write it like this? 15 is equal to 7 into 2 plus 1. Okay, this 7 is nothing but my divisor, this is nothing but my divisor, this is nothing but my quotient, and this is nothing but my remainder. Okay, and this is nothing but my dividend. Okay, dividend, I'm writing it dd. Okay, so here let's suppose this 15, here I am writing 15 as s1. S1 is nothing but sum of numbers, few numbers. Okay, 15. Can I write it like this? K, it is a divisor, into quotient plus remainder. Okay, so I can write it like this. Okay, so here let's suppose this is my nums array given to us. Okay, nums array given to us. Okay, so here I am finding the sum. I am finding the sum. Okay, so 3 plus 6 plus 6 is nothing but 15. Okay, and when I divide this 15 with 7, okay, let's suppose my k is 7, then I am getting my remainder as 1. Okay, and here when I take this complete array, okay, 3 plus 6 9, 9 plus 6 is 15, 15 plus 4 19, 19 plus 3 22. When I divide this 22 with 7, then again I am getting the same remainder, right? Same remainder r. Okay, 1. Then again I am getting the same remainder here, see, 1. Okay, so from here can I say one thing? See, okay, so here let's understand it like this. This is my s1 and this is my s2. Okay, this is my s1. Okay, this is my s1 and this is my s2. Okay, now I want to check for this part. Okay, this curly braces, this part, this complete remainder is 1. Okay, s2, this part s1, remainder is 1, and I want to check this mid part. Okay, so can I write it like this? S2 minus s1. S2 minus s1 is going to give me the going to check for this mid part. Okay, so let's do that. See here, s2 minus s1. So can I write it like this? This k. Okay, let's suppose these numbers are different. This is 2 and this is 3 here. Okay, let's say I am using n hyphen. Okay, so k n plus remainder is same at both times, k n plus r. Okay, this is my k n hyphen plus r. This is my s2. Now I have to write s2 minus s1. So here s1 is k n plus r, right? Okay, so can I write it also like this? S2 minus s1 is equal to k n hyphen minus n, and this r and r is going to cancel out, right? So this is done. Okay, this is going to cancel out, right? So here, from here one thing is clear. Okay, this is going to be 0. This is going to be 0. Okay, because r and minus r is going to cancel out each other. Okay, so from here one thing is clear, that suppose this is my dividend. Okay, this is the part that I want to find, right? So here s2 was nothing but my 22 minus 15. 22 minus 15 is nothing but 7, right? 22 minus 15, okay, is 7. Okay, is equal to k is nothing but my 7, and here n hyphen minus n hyphen. Okay, n hyphen minus n plus 0. Okay, so from here this thing is clear, that this part is going to be completely divisible by my 7. Okay, this is what I want to explain. Okay, this part 7. Now do the 7 modulus of 7. You will always get a remainder as 0. Okay, so if any two numbers, okay, any two sums, okay, so see here, s2 is still here now until here, and s1 is until here, and we were getting the same remainder both the times. Okay, that simply means that in between, if I do s2 minus s1, that simply means that this part is going to give me the remainder as 0. Okay, so this is one important point that I want to explain here. Okay, and now let's move to the second important basic math property. Okay, so if I want to divide a negative number with 7, then what should I write? Okay, so if I divide this minus 36 with 7, then this is nothing but my divisor. Okay, minus 36, right? This is 7 is nothing but my divisor. This quotient is minus 5 and remainder is minus 1 this time. Okay, this quotient, this remainder is -1. Okay, and can I also write this -1 in some different form? This remainder, can I change this -1 in a positive number? Can I change this -1 remainder in some positive form, in some positive number? Can I change it? Yes, I can change that. How can we can change that? So here what I am doing here, 7 into -5, same thing, -1, and here I am adding one additional part, plus 7 minus 7, plus 7 minus 1, -7. Okay, so it is not going to impact anything. Okay, this part is going to give me 0 only. Okay, so here what I did, I have added plus 7 minus 7, the same divisor. Okay, k value, plus k minus k. Okay, plus k minus k I did. So here once this is done, then 7 into -5, and then I am bringing this -7 here. Okay, -7 here, and here this 6 is nothing but -1 plus 7. Okay, -1 plus 7 is 6, and here I am bringing -7 here, and I can also write -36 like this, 7 into -5 minus 1 plus 6. Okay, so here this 7 is nothing but divisor, same, and quotient this time is -5 minus 1 minus 6, and here remainder is 6. Okay, so this 6 is going to be the positive form of the negative remainder. Okay, positive form of -1. Okay, for this particular case. Okay, so here this is how we are going to calculate the positive remainders. Okay, so I hope that this basic math property is clear. Okay, so here see, -36 is equal to -36 if I do this, and here also -36 is going to be -36. Okay, if you do the solve this, so -7 -5 -1 is -6, -6 into 7 -42, -42 plus 6 is -36. Okay, so here this is how we convert our negative remainder into positive remainder. Okay, so why it is required? Okay, so it's go to -36 divided by 7, -36 mod of 7, and you are getting this. Okay, so why we need this, why we need to convert our negative remainder into positive remainder? Okay, now this is the question, why we need to convert this negative remainder -1 to a positive number. Okay, okay, so now let's understand this with this example here. Okay, so we have to use one hash map actually. So here in the hash map I am going to store my remainders and the counts. Okay, how many times these counts are occurring. Okay, so initially I'm taking my sum as 0. Okay, initially I'm starting from sum as 0. Okay, so if I am dividing my sum, which is 0, divided by k, then in that case I am going to get my output, some output. Okay, so my remainder is 0 initially. Okay, so how many times I have encountered 0? So initially this is going to be my base case. Okay, so this is going to be my base case. Okay, initially my sum is going to be 0 every time, and I am going to add count as 1. Okay, so this is what I need to put in my map. Okay, initially. Okay, now after that, see, after that what's going to happen, if I do the cumulative sum 0 with this -1, then I am going to get the output as -1, right? And here if I do the -1 and take the remainder, okay, -1 divided by 2, I am getting the remainder as, okay, initially this 0 here, and here I am going to get remainder as -1. Okay, -1 is not there in my map, so I am going to put it into my map, -1 and count of this 0. Then again after that, this here see, here when I do the addition, -1 plus 2 1, and then I divided this 1 with my k value, then I'm going to get my remainder as 1, right? So see here, 1 is there in my map? No, it is not there, so I am going to simply put it 1, and here I am going to increment the count as 1. Okay, here here it should be 1. Okay, -1 is also occurring one time, and 1 is also occurring one time. Okay, this is done, but here there is one mistake actually. There is one mistake actually. Okay, so let's see what's the mistake here. Okay, so now if in case, what I'm saying, I want to change this -1 to a positive number, if I want to change this -1 to a positive remainder, okay, so then how can I do that? So from here one thing is clear, I have to just add k. I have to just add k in my negative remainder. Okay, so my negative remainder was -1, and here when I added this k value, 7 value here, plus 7, then what was the result that I am getting? 6. okay, 6, I am getting 6. So this 6 is a positive form, right? So I can simply convert my negative remainder into positive remainder by just adding k value here. So if I just add k value in this my negative remainder, minus 1 plus k is nothing but it is going to give me 1. Okay, so here instead of minus 1 I have to store 1, and how many times 1 occurs? 1. Okay, after that I move here 1, and 1 was already there now. Okay, so here I am talking about the example if I convert this negative remainder into a positive remainder. Okay, so I have converted into positive. Now see here, when I do the summation, minus 1 plus this 2 is going to give me 1. Okay, this 1. So when I do the remainder of 1 divided by 2, then I found that this 1 is already there in my map, right? It is already there in map. So here what's the point, what is clear here? So tell me. Okay, so here see, until here I know that remainder was 1. Okay, so now you will see one important point. Until here I was saying that remainder is 1, and here also you are saying that remainder is 1. Okay, here you are also saying that for this complete part, minus 1 plus 2 is 1, 1 divided by 2 is 1. Okay, so here you are saying that for this complete part remainder is also 1. Then in first thing that I have explained here, that in S2 minus S1 definitely I am going to get some result which is going to be completely divisible by my K. So see here, so until here, see, until here my remainder is 1, until here also my remainder is 1. So in between, in this zigzag part, I am getting that sum which is going to be completely divisible by my K. What is the value of my K? Is nothing but 2, right? So this part is completely divisible by 0, completely divisible by my K. So definitely I am going to get one result here. But if in case I was using this negative number, then definitely I am going to miss this part. If I am just converting this into positive and then I am checking, then I am good. Okay, then I am getting that there is one number which is going to completely divisible by my K. Okay, so that is the use of this hash map here. So I am going to change this frequency of 1 to 2 times. Okay, 2 times I have found this same remainder. Okay, that's the only reason I have found that this remainder already exists if it is equal to some previous one. Okay, and in the result, initially my result is 0. Okay, in the result I am going to add my previous value. What was previous value here? 1. Okay, so this is done. 0 plus 1, this is done. After that, what is the cumulative sum that I am going to get here? So 9 plus 2 11 minus 1 is 10. Okay, so here 10. So 10. Okay, when I am going to divide 10 divided by 2, so I am going to get 0. Oh, okay, I am getting 0. 0 is already there. 0 is already there, right? So here what I am getting, see here, this is 129. For this whole part, my remainder is 0. For all this part, my remainder is 0. And initially also my remainder is 0. So definitely in this part, there is one number which is going to be completely divisible by K, right? This part, okay. So see here, initially my sum is 0, remainder is 0. And for this complete part, I am find that my remainder is 0. So definitely in between this part, zigzag part, there is one number, one sum which is going to completely divisible by 2, right? K. So definitely I am going to compare this to 2 and add this one here. So I am going to get the result as 2. Okay. So now let's understand this with the example number 1. Okay. So this will give a more clear picture. Okay. So here initially my sum is 0 and my sum is 0, but this k here initially k is 5, right? Initially my k is equal to 5. Okay, so when I'm going to divide this 0 with 5, I'm going to get a remainder as 0. Okay, so initially my remainder is equal to 0. Okay, so let's use a hash map. Let me create that. Okay, this is done. Okay, so here I have to store my remainders, and here I have to store count. So initially when my remainder is 0, so count is 1. Okay, one time it occurs. Okay, so let's put it. So by default I have to add this every time, this one thing. Okay, so now when I add this 4 to this sum, what is the total sum that I'm getting? 4, right? So now where can I divide this 4 with 5? 4, can I divide this 4 with 5? Then what is the remainder that I'm going to get? Tell me, what is the remainder that I'm going to get? 4 is the remainder that I'm going to get. Okay, so this 4 is there in my map. No, it is not there. So here I have to add 4 and change the count to 1. Okay, this is done. Then I move to next place. 4 plus 5 is 9. Okay, now let's divide this 9. Let's divide this 9 with my 5. So what is the result that I'm going to get? What is the remainder that I'm going to get? So 9 divisible by 5 is going to give me the remainder as, so let's do 9 is there. Okay, 5 1 5, and I am going to get the remainder as 4. So 4 remainder is already there. 4 remainder is already there. Okay, so now see one thing here. Until here remainder was 4, and until here also remainder was 4. So definitely in this green color part there is one value which is going to be completely divisible by my k. So yes, that is right. 5 minus 5 is completely, 5 modulus of 5 is going to give me 0, right? It is going to give me 0. So definitely what I am going to do, so in my result, okay, so this is clear. So in my result, initially my result was 0. Okay, initially my result was 0. So in my result I am going to add, 4 is already there now, one time. So I am going to add this value 4. What is the value in front of 4? Count 1. I have added this 4, and now how many times 4 is in count of 2 times. So here I am going to update this value to 2. Okay, I have changed this value to 2. Okay, this is done. Now after that I move to next position. So here 4 plus 5 plus 0 is again 9. Okay, so now what is the remainder that I'm going to get? Again I'm going to get the same remainder, right? Again I'm getting the same remainder. Now in the result I have to add this 2. Okay, I have to add this 2 here, and I have to update this to 3. Okay, and this to 3. Okay, so now tell me why I am adding 2 here. Why I am adding this 2 here? So simple, see here, until here my remainder was 4, and in this whole part my remainder is 4. So definitely this number is divisible by 5, and 0 is divisible by nothing but 5. Okay, this is one part, and there is one more part. There is one more part, right? So this is one part, and here until here remainder is 4, and until here also remainder is 4. Okay, this is until here also remainder is 4. Then definitely this part, this zigzag part, it is also completely divisible by 5. Okay, 0 is also completely divisible by 5, right? So definitely I have shown you the two values now. What are the two values that we are getting? One this value, and one time this complete value. Okay, so all these values are there in my result. Okay, so now my result becomes 0 plus 1 plus 2. Okay, so see here, first 5 I have already 5, then 5 0 I have already. Okay, these two values, but and we have found it 3 values, right? So what is the other value that we have found it? See here, 1 is 5. Okay, here 1, when I have added this 1 for this 5. Okay, and here I have added 2 values, and what are those 2 values? Those 2 values are this one. Okay, 5 and 0, and this 0. Okay, so this, see, 5 0 is there, 0 is also there, and 5 is also there. Okay, so I have added 10 here. Okay, now I move to the next part. 9 minus 2, what is the total sum that I'm getting? 7. Okay, so 7 divided by 7 divided by 5 is nothing but it's going to give me the remainder as 2. Okay, 2 is there in my map? No, 2 is not there, just add it. So count is 1. Then after that I move to the next part. 7 minus 3 is nothing but 4, right? And 4 divided by 5, what is the value that I am going to get now? 4, I am dividing this 4 with 5, so I am going to get the remainder as 4. Okay, so here simply I am going to add this time, but this 3 value, 4 is already there now, this 3 I have added, and I am going to change this 3 to 4. Okay, I have updated this to 4. And now what are the three values that I am adding here? Tell me, what are the three values that I am adding here? Okay, so see here, until here it's 4, and in this part also it is 4. Okay, so in this part definitely this subarray sum is equal to which is going to be divisible by 5. So 5 0 minus 2 minus 3. Okay, this is one part. So let's add that 5 0 minus 2 minus 3. Okay, three values that I'm adding. This is first value. Okay, this first value is clear. Now let's move to the second value. What is the second value that I'm going to add here? Okay, so until here also remainder was 4. Okay, so definitely this part is going to be completely divisible by 5. Okay, so 0 minus 2 minus 3. Okay, this is done. Then until here, okay, until here also our remainder was 4. Okay, so definitely in this zigzag part, okay, this color part, definitely these values are also going to be divisible by 5 completely. So minus 2 and 3. Okay, minus 2 and minus 3. Okay, this is done. This is done, right? Now that's it, that's all. Okay, now let's move further. Now after that I recheck this expression. 4 plus 1 is nothing but 4 plus 1 is nothing but 5, and 5 divided by 5 is 0. Okay, 5 divided by 5 is 0, right? This is done. 5 divided by 0. So 0 is there. Yes, 0 is already there. 0 is already there, right? So initially till here 0 was there, and until here also I am getting 0. Okay, so definitely this is sub array where I am getting the same result. So here 0 of count is changed to 2, and I have to write this complete set 4 5 0 minus 2 3. Okay, this complete part, and I have to add this right here plus 1 here, and which one is there? This is this value. Okay, so now what is the total result that I am getting? What is total result that I am getting here? See, result, count my result. Okay, 0 plus 1 1, 1 plus 2 3, 3 plus 3 6, 6 plus 1 7. 7 is my output. Yes, 7 my output. Okay, so I hope that you guys are clear why we are taking how we are using this maps, hash maps, and how we are using cumulative sum, and what is the role of this positive remainder every time that we are taking. Okay, and how we are applying this s2 minus s1 formula. Okay, so I hope that you guys are clear with all these basic mathematics operations. Okay, so now let's move to the coding part. Okay, so I am going to use the same thing that I have explained. Same, everything is going to be very same. Okay, so let's move to the coding part. Video, I think it's going to be very lengthy maybe, right? So first int n is equal to nums dot length. Okay, so and then we have to use hash map, and in hash map I am storing my remainders and count now, so both are integers. So let's use integer. Let's name it as map, new hash map. Okay, this is done. Then after that initially my sum is 0, and I am saying one thing every time. See here, every time my sum is 0, initially I am adding these values by default, 0 and 1. Initially every time my sum is 0, and whenever I am dividing this sum with my k, every time I am going to get the remainder as 0. Okay, so here I can simply write this by default every time. Map.put 0 and count is 1. Okay, this is fixed. Okay, I have already explained this part. And initially my result is 0, and then I have to run one loop. Okay, for this case time complexity is going to be of n just. Okay, I is equal to 0, I is less than n, I plus plus, but there is a lot of mathematics right in this problem. And sum is equal to sum plus nums of I, and here I have, how we are going to calculate the remainder? Int remainder is equal to nothing but sum modulus of k. Okay, this is how we are going to calculate the remainder. And one thing that I have explained, if my remainder is negative, then what we need to do, okay, this should be small r. If my remainder is negative, then we have to just add k value in my remainder, right? I have already explained this part as well. Okay, and this is done. And if the value, okay, if that particular key, that is remainder, if it is already there in my map, then what we need to do, contains key. Okay, so I am writing the same story, right? Same story. Okay, if it contains this key remainder, okay, if it contains that, then in that result we have to add that value, right? Result is equal to result plus map.get remainder. Okay, and if it is not there, then simply put that value. Okay, map.put. Okay, if it is there or it's not there, so we are going to use get or default method. Okay, if this map.get map.put remainder, if it is there, okay, so let's use this get or default. Okay, get or default. If it is there, then use this rem, otherwise just use 0 and add 1 in it. That's it. Okay, and in the end we have to just return result. Okay, code is done. Okay, we have to just return the result, and time complexity for this is going to be of n. Now let's run it and see if there are any code issues. Yes, so there is one spelling mistake. Okay, here I have to write map dot na. Okay, anything else? So all the test cases has been accepted. Now let's submit it. So see, all the solutions has been accepted. Okay, so our solution is submitted, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. And till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.